My name is Ian Kipto and I'm the model architect at Infinity Modeling Labs. Today we are going to discuss about dimensions. So we can start with a normal two-dimension. So in a two-dimensional space, you have a reference point, or you use two. Actually, you use two references to describe or measure uh, points an object, and the reference point begins with the one dimension, a dot. So when you have two dimensions, you have two references. For example, if we pick, let's say, we want to capture an object in 2D. For example, even with the phone camera, if you lay it like this and then you capture an object, let's say a picture of the ground, you have the element of length and width. So you can accurately capture the length and the width. So this is an example of a two-dimensional capture. Say you now have your camera like this. You now have a two-dimensional capture of height and width. From now the capture either this way or this way, what you see is you're only capturing an element in two dimensions. So how do you get the third dimension? So you get a third dimension by adding the element of depth. Because say you capture an object like this, now the height aspects of the object are limited and are not accurate. And if you capture like this, the length aspects are limited. So how do you capture a 3D? So say if we were to capture a 3D image of, let's say, me as I'm sitting, you need to have a camera here, here, top, bottom, so you have an all-round view of the object or the image. So essentially, a 3D image has different properties from a 2D image. 3D image has one definitive characteristics in that it has elements of the object defined in all the three axes, the X, the Y, and the Z. Unlike if you capture 2D, you're either capturing X, Y, or Z and X. For example, if we see from how to get like a 3D, if say you capture uh, the length and the width of an object in 2D, expand even if the length aspects or the width aspects indefinitely, you will still not get 3D. What do I mean? You get 3D by integrating the height aspect if you're now doing it this way, or you get 3D by integrating the length aspects by capturing an object all round. So essentially, 2D just captures two references, and 3D, you need now the all round references. Essentially, that describes modeling. And what is modeling? Modeling is creating an object from its characteristics. So you can either capture it with a photo, or you can even draw, you can even generate it in a computer. But as long as it's only between the two axes, you're modeling two-dimensional object. And if in case you're capturing from all angles, you now have a three-dimensional object or image. There is one aspect of 3D that proves that an image or an object is actually in 3D. That one you can have by using the cube that labels dots, each dot with a coordinate. Meaning if you capture an image, you're able to get the model of the image and its image properties in reference to the X, Y, and Z coordinate. And this is actually technology that is available through their 3D scanners, where you can accurately capture external points and characteristics of an object, color, sizes, now measurable, as long as you get the coordinates in terms of X, Y, and Z. So you can get the actual distances and coverage. So in 3D capture, how to describe an object now would depend mainly on the number of dots you have generating the object. What do I mean? Take an example, even the lens pixels. Just from the 2D, if you have an image of a lower pixel, the image is not clear. But increase the intensity of the dots, you now get a clearer image in 2D. So the same way with 3D. If you have more points in terms of capturing the object or generating it, you have a clearer view of the object. So, and the object can be clearly defined with more dots showing curvatures, characteristics, everything. And even, for example, in applications like engineering, to accurately capture maybe sensitive parts in machines that need high accuracy, you have more dots. So the same concept is the same. Now, we want to discuss now even beyond 3D. We have aspects of fourth dimension, what it is, aspect of the fifth dimension, what it is, and the sixth dimension. So we'll discuss all of it step by step and with examples. Mainly 3D will focus on the external physical characteristics. If you have the external physical characteristics of an object and you capture it in 3D, you can get accurate description of it. But say if it is hollow in between, you do not have, you have like some gray area, because unless you use maybe penetrative imaging to maybe get to know like what is underneath or beneath it, then now you can have a fully 3D. So if you have a 3D imaging, for example, of something that includes even the interior characteristics of it, then you have a fully 3D. From the modeling of the 3D, we have what is missing. For example, to bring about 3D from 2D, you add an element of depth and you get now 3D. So if you're modeling in terms of, say, the fourth dimension, there is how you go about modeling from getting a 3D to the fourth dimension. We have a model that we generated, a model of the Earth. So we put the Earth inside the cube model with the dots in the X, Y, and Z coordinate. So what we did and how we generated the model is we took not 2 points, not 2 references, but we took 3. For example, if you take 2 references, if you want to model, say, the Earth, you would take a reference, say, latitude and longitude. If you take the reference of latitude and longitude only, you get a round model of the Earth. But if you're to look at it keenly, is the Earth fully round? No. So if you only use 2 dimensions, it means you can add a third element and get now a better depiction of the Earth. Now what we did is we added the element of altitude. So the same way latitude and longitude can be used to define every point along the Earth, we now added the third element of altitude. So with the altitude, we are able now to get the true shape of the Earth, because the Earth has hills, valleys, and gradient topographical differences. So if you incorporate that into the model, you get a 3D model of the Earth that has the 3 references captured all over. So how you get the fourth dimension is, one, from the cube model, you just add dots. Add dots all over the surface and the interior. Remember, as we've discussed in terms of even the pixel of imaging, the more the dots, the better the imaging. So even on the surface of the Earth, even what we see, when you add a lot of dots, you are able to get a clear view of the surface. But then now we add not only on the surface, also in the interior. With the surface and the interior, we're now able now to add other characteristics into the model. So what are we trying to do? We are trying to generate a model that has all the all the information that we can in terms of to describe, say, the Earth in one model. Say an element of like population. You can use one dot to represent one person. So from the model of the surface of the Earth, and you have maybe census data, you can have population distribution and attributes into now the same model. The same dots, if you cluster them together, you're now able to get things like geographical formations. For example, if you have a mountain, you know with this cluster of dots, they form a mountain. This cluster of dots form a valley. This cluster of dots represent, let's say, the water bodies. This cluster of dots represent land. This cluster of dots from here to here represent maybe Kenya. With integrating aspects of the dots with now their references or use, you're now able to have all this data in one. Say, for example, even you want to model the chemical formation or the chemical attributes. Say you have resources like minerals. Using the same model, you're able now to have like the same points on the surface now with negative altitude, and you're able to model subsurface. So the more you're modeling and the more you're adding things to the model, is the more you're creating a more realistic picture or a replica of the Earth. And that is the process on how we get about the fourth dimension. You add aspects of chemical, you add aspects of, you can even add aspects of financial. The wealth distribution, every dot represents maybe a certain amount, and you have now the wealth distribution all over the world. Then you can also do resource distribution, like how is the resource distribution, water distribution, clean water, salt water. So you can create thousands of models just from the same model. As we see, for example, that point model of the cube now with the x, y, and z coordinates is able to hold a lot of information into one integrated. So what we see is you're able to have more information in a 4D model, in a 5D model, as opposed to a 3D or a 2D. So the limitations are even in terms of what you can add. So anything generative from the data we have, you can put it into the model. So what else can we add into the model using the same specifics? So we can add things that have existed before, things that are natural. For example, you can add plants and animal data. For example, you can have a 3D scan of a given plant, a given animal. Even for, let's say, the human body, you can use the same aspect of dots to get the exterior physical model accurately. For example, in a picture, we have like, you can describe, let's say, a person by how he is uniquely, even the facial characteristics, DNA, fingerprints. These are things that you can now formulate using dots and have them generated and get the features in 3D, right? And then now the same dots added, and you get, let's say, you're able to model internal systems like the blood vessels, organs, things like that. Now, once you integrate everything into one model, you now go to the processes bit. I was explaining about how you can add even plants and animal data using the same process. Now, for example, when it comes to, let's say, the plants or animals that exist, you cannot have the generative aspect of modeling in that you now start generating it from scratch. It's easier to just capture duplicate. What I mean is you can just scan the object, get its physical characteristics, and you know this is a particular tree, this is a particular plant, this is a particular animal. So once you do that, and then the same way now to get maybe 4D of the plant or animal that exists is you also have a model defining characteristics of the chemical characteristics, how is it internally. So it's just the same concept you can use across. Take an example, we have done the model of the Earth. You can use the same concept to have a model of, say, Neptune, say the sun. So it's the same concept, and that's why we're describing the dimensions in detail, because each dimension has a unique characteristics. There is what 3D adds to 2D, and there's what 4D adds to 3D, and there's what 5D adds to 4D. And then now we have finally the sixth dimension. And now there's how they all interact with one another. So that is the essential purpose of what we are doing as Infinity Modeling Lab, because we focus and specialize on the dimensions and how we can apply and use them in daily life. We have discussed how you can add elements, both generative now from data or through scanning. And once you get once you have all of it in one, you now go to the next stage of 5D modeling. So 5D modeling models processes. Even here on Earth, we have things that have existed from before. So how you also model that is by the aspect of mirroring. So mirroring is, for example, you take a scan or a 3D scan of, say, a given tree, a given plant, a given animal, and you're able to have its physical characteristics defined by the X, Y, and Z coordinates in the points. And then same process. You add the dots definitively in its interior, and you're able to model even the chemical aspects, process aspects of that go on within the system. Also, what we have done, for example, with the model of the Earth, you're able to do the same process also, and it applies accurately. For example, if you want to model Neptune, if you want to model the Sun, if you want to model Jupiter, even even the universe. Because, for example, we have a model of the infinity universe, where we have Earth at the center with its size, and then Sun and the planets with its accurate distances. So what we did is we just placed the same cube model with the X, Y, Z coordinates, and then plot distances, uh, plot the object characteristics, like the Earth, how big is it, what is its orbit, how does it revolve, and then you just integrate it to the model. So depending on how far maybe we have, for example, scanned through the universe, you can create a model of how far we have seen, and how the location of the objects, the characteristics, how it moves. So you can have an accurate depiction of the universe better in 3D. And once you have, for example, all the characteristics in one model, you now go now to the fifth dimension. So the fifth dimension has the process bits, the functionality, how it works. And not only how it works, also the seed aspects of how do things replicate, how do you get another thing from something. So and then finally, with all the information in one, you get the blueprint of, say, the universe, man, or Earth, and how best you can describe it. The 6D elements is the subconscious and the conscious. Subconscious comes about dependent on the process of and the timeline of creation. Like the first day, second day, third day, there is what was made. Then there is what was created last. If you can see, for example, all the data on what and how everything was created. For example, the last creation was man. We can see how everything came about in terms of now matter. Everything came from water. Then the water, we got land from water, and then now man was created from the land. Now, the same way, if you continue subtracting, what's the smallest model? The smallest model is the conscience, because man was created with a conscience. So the conscience is where the thoughts come from and where ideas come from. It guides all these other elements. So the sixth dimension guides all these other dimensions and operations. If we see like now the case from say Adam, he was created, and then we had the aspect of now him being shown everything else. Now him being shown everything else, how that happens is the subconscious integrates with the conscious. So the subconscious is like the blueprints of everything. So that was able now to integrate with his conscience, and they drew parallels and they are similar. Essentially, just to describe the sixth dimension, is that the conscience has the potential of mirroring the subconscious. How, for example, man, we have the ability to show the image of God. So, because everything was created and the subconscious are like a blueprint, and then we have the conscience. So, the journey of dimensions actually is the development of the conscious to, once it's fully developed, it becomes one with the subconscious.